You know that feeling when you're on a website and it's just super fast, super interactive? Well, a lot of the time, the magic behind that is a library called React. And today, we're going to walk through the entire journey a developer takes with it. We're talking from the very first building block all the way to a complex, polished app. Let's dive in. All right, so here's the game plan. First up, we'll answer the big question. What is React anyway? Then, we'll get into how we actually make an app feel alive with data. That's state versus props. From there, we'll build it out into a full multi-page experience, figure out how to handle it when things get complicated, and finally, we'll polish it up for peak performance.
Okay, let's start at the very beginning. Every great app has a solid foundation, right? For React, that means understanding its core building blocks. So what is this thing really?
Okay, so at its core, React is all about one thing: building user interfaces. And its big idea is actually super simple, but really powerful. You break down your entire interface into these small, reusable pieces called components. Seriously, think of them like Lego bricks for a website. The real magic of React, though, is how it manages all those bricks, automatically updating them whenever any data changes. So you might be asking, how do we actually write these little Lego bricks? Well, that's where this amazing thing called JSX comes into play. It lets you write what looks exactly like HTML right inside your JavaScript file. This is a game changer because you're not juggling separate files for structure and logic. You combine them in one place, which just feels natural. You get the simplicity of HTML, but with all the power of JavaScript right there. And look, this right here shows you exactly why JSX is so cool. On the left, you've got JSX. It's clean, it's readable, you know exactly what it's supposed to be, a heading that says Hello World. On the right, that's what you'd have to write in plain JavaScript. It's a lot. JSX isn't just about saving a few keystrokes, it's a completely different and, frankly, much better way to think about what your UI should look like. Okay, this is probably React's biggest claim to fame. It's its secret sauce for performance. See, traditionally, when something changed on a web page, the browser had to redraw the whole thing. Super slow. But React is smarter. It keeps a lightweight copy of the page in memory, called the virtual DOM. When data changes, React updates this virtual blueprint first. Then it plays a little game of spot the difference with the real browser page. It finds only the tiny bits that actually changed and updates just those. No more full page reloads. And that's why React apps feel so snappy. All right, so we've got our super fast building blocks. That's great. But a website with just static blocks is, well, it's pretty boring. To make things interactive, to bring them to life, we need data. And in the world of React, data really boils down to two key concepts: state and props. And getting this difference is maybe the most important thing in early React development. It's absolutely crucial. So think of it like this. State is a component's own internal memory. It's its data. It owns it, it manages it, it can change it whenever it wants. Props, on the other hand, are like instructions or settings that are handed down from a parent component. They are read-only. The component can use them, but it can't change them. It's like, here are your orders, now go do your job. So, how does a component get this internal memory we're talking about? Well, we use a special tool from React called the useState hook. This is basically the go-to tool for making anything interactive. Let's say you have a like button. The number of likes, that's its state. When you click the button, you call a function that useState gives you to update that number, and boom, React takes care of redrawing the component on the screen with the new count. Okay, but what happens when two separate components need to know about the same piece of data? Like a shopping cart icon and a checkout button both need to know how many items are in the cart. They can't just talk to each other directly, so what do? You use a really common React pattern called lifting state up. It sounds fancy, but all it means is you find the nearest parent component they both share, move the state there, and then that parent passes the data down to both of them as props. It's the standard way to keep your data in sync across your app. All right, cool. So we can make individual components that do stuff. But a real application isn't just one button or one little widget, right? It's a whole collection of pages. So how do we build that full experience, letting users click around from, say, the home page to the about page and then to the contact page? Well, for that, the community has a standard solution, a library called React Router. It's the secret sauce that lets you create different pages or views in your app. And the best part is, when you click a link, the browser doesn't do a full clunky page reload. The content just swaps out instantly. This is what makes a single-page React app feel like a traditional multi-page website. Now, our components can't just live in their own little bubble. they often need to reach out and talk to the outside world. Maybe they need to fetch some user data from a server when they first appear, or connect to a live chat service. In React speak, any of these outside interactions are called side effects. And to handle them, we have another super important hook: useEffect. But here's the really smart part about uEffect. It's not just about starting things, it's also about cleaning up. Think about it. If your component subscribes to a service, what happens when that component disappears from the screen? You need to unsubscribe or you'll create a memory leak. uEffect makes this easy. You can just return a function from it, and that function is your cleanup crew. React will automatically run it when the component is removed. It's brilliant. So we're building. Our app's getting bigger, more complex. And as it grows, we start running into some new challenges, especially when it comes to juggling data across a whole bunch of components. And this right here, this is a classic problem that every React developer hits eventually. Picture this. You've got the user's name stored way up at the top level of your app, but a tiny little component, buried, say, 10 levels deep inside other components, needs to know that name. How in the world do you get that data from way up there all the way down to there? Yeah, that painful process has a name. It's called prop drilling. And it's exactly what it sounds like. You have to pass that data as a prop through every single layer of components in between, even if 9 out of 10 of them don't care about that data at all. It's a huge pain, and it makes your code really messy and fragile. Thankfully, React has an elegant built-in solution for this exact problem. It's called the Context API. The idea is simple. You create a sort of provider for your data at a high level in your app. Then, any component anywhere below it, no matter how deep it's nested, can just subscribe directly to that data. It's like a teleportation device for your data, skipping all the layers in between. So yeah, no more prop drilling. Now, when applications get really big, we're talking massive enterprise-level stuff with super complex data flowing everywhere, developers often reach for an even more powerful tool called Redux. You can think of it like the Context API on steroids. It's all about making your application state predictable and way easier to track and debug at a huge scale. Okay, we've made it. Our app works, it's got pages, it's managing data, it's well-structured. But are we done? Not quite. Now comes the final, crucial step: polishing. We need to make sure our app isn't just functional, but that it's fast, efficient, and can handle errors gracefully. It's all about optimizing for that peak performance. And React gives us a whole suite of tools to do just that. There's Memo, which basically tells a component, hey, if nothing's changed, don't waste time re-rendering. There's Use Callback and Use Memo, which are fantastic for stopping your app from recalculating the same expensive stuff over and over. And you've got Keys for lists, which helps React be super efficient when adding or removing items. It's all about preventing wasted work to keep the app feeling snappy. But what about when things inevitably break? A single JavaScript error in one tiny component can crash your entire application. Not good. That's where error boundaries come in. Think of them as a safety net. You wrap a part of your app in one, and if anything inside it throws an error, the boundary catches it, shows a nice fallback message, and stops the whole app from going down. This is absolutely essential for any real-world application. And one last trick for a great first impression: making that initial load time super fast. Instead of forcing the user to download your entire giant application up front, you can use something called code splitting. You just send them the bare minimum code they need for the first page. Then, as they navigate to other parts of the app, you load those pieces on demand. It's a huge deal for user experience. It makes the app feel like it loads instantly. And there you have it. That's the developer's journey in a nutshell. From that first single component all the way to a complex, scalable, and highly optimized application. What React really does is give you the tools to take this huge, complicated problem of building modern user interfaces and break it down into small, logical, manageable pieces. So now that you've seen the roadmap, the only real question is, what are you going to build next?